So I'm Jenny.
I'm Michael.
I'm Lacey. I'm Carolyn.
And we're going to be talking about our project, which was an investigation of potable water initiatives in the Lake Atitlan region of Guatemala. So we initially went to kind of look at how to make this one type of biosand water filter more sustainable. And in looking at how to increase the sustainability of this water filter, we also began to question whether or not it was the best filter option for this region. And so we have kind of two components of our project that we'd like to discuss. As a little bit of a background, about 40% of the rural population of Guatemala currently doesn't have access to potable water. And so this is especially acute around the lake. You can see in the picture here, it's pretty steep terrain, and coupled with that, frequent mudslides and hurricanes just make it really difficult to maintain any sort of water treatment or distribution centers. And so in addition to this, there's not really many wastewater treatment plants, and the excessive use of fertilizers for their agriculture on the lake has led to a lot of nutrient overload within the lake. And so for the past few years, they've had a bunch of cyanobacterial algae blooms. And this is especially a problem for communities who draw their water directly from the lake. Studies have shown that in young children with recurring cases of diarrhea, this can actually stunt their neurological development. And so it's definitely an issue that we would like to address, is just providing this potable access to potable water. So this is a HydrAid Biosand filter. In 2010, a group of students from UVA went to a town called Sunana on Lake Atitlan and brought 13 of these filters to be installed. So there's two components. There's the plastic shell, and the inside is basically just sand. And right now they're imported from Michigan. And so it's pretty unsustainable because you have to send them all the way from Michigan to Guatemala. So our project was initially looking at how can we find a local sustainable source of this aggregate to be used in these filters.
Great. So here we go. So in order to so technology. In order to assess the local availability of aggregate sources for the HydrAid filter, our team conducted surveys in different quarries and hardware stores in and around Quetzaltenango, the second largest city in Guatemala, and the Lake Atitlan region. We asked questions regarding the origin of the aggregate, as well as the testing performed on the aggregate in conjunction with HydrAid standards for use in a HydrAid filter. And we asked questions regarding costs, sizes, and the transportation costs to the lake region. Let's see. We found that the best source of aggregate came from Checaraco, which you can see here is a large quarry that uses explosives to take the aggregate from the center of the mountain, which was found to be the best source of aggregate. They performed 7 different tests as opposed to the different quarry operations that we found, which generally performed no tests, which meant that organic contamination and metal contamination were potential problems. Let's see. In addition, Aggregate had environmentally sustainable practices. They would reforest the area that they quarried, and they also had different community programs to help mitigate the effects of quarrying, such as lending materials, building materials to the nearby community. So having found a suitable source of aggregate to use in the HydrAid filter, our team decided to address some of the concerns that had arisen throughout our initial investigation. Namely, we were concerned that we might be imposing the HydrAid technology throughout the entire Lake Atitlan region, where it had only been introduced before in one small community. And we were aware that every community had its own geographic, unique characteristics and cultural considerations. So in addition, we saw a plethora of different projects and filter initiatives already ongoing, but we saw a lack of communication among these organizations. So we decided to design a a community assessment of the 15 largest communities around the lake, looking at the different needs within and among these communities.
While taking a step back from looking at the HydrAid filter, we decided the survey for the community assessment included all of the communities around the lake, and we interviewed municipalities, health centers, and community-based organizations with a standard set of questions. When we visited municipalities, we asked about the water sources, water treatment methods, and any testing methods that they used. And when we spent time with community-based organizations, we wanted to learn about the scope of their projects. What was the size of the population being served, as well as the scale of the water filtration or purification method. At health centers, our focus was to find out their perception on how water quality affected the health outcomes in the area. And for data analysis, we identified themes from these interviews and compiled them into profiles for the community-based organizations, the water filters, and for each individual community. You can see here a profile for an NGO and for a water filter. With these profiles, we were able to quickly show the advantages and disadvantages and where they're used along the lake. The information from interviews with key players in the communities were compiled into community profiles. With these, we were able to show the unique characteristics of each community that would have implications on the type of water filtration that's most appropriate for that community. For instance, we could say whether communities pulled their water from the lake or if they were on really steep terrain that makes some projects better or worse than others. For example, in Sununaa, Guatemala, where the HydrAid filters had been installed by previous UVA groups, even the urban center is in very steep terrain, making the filters hard to carry up the hills. But in another community along the lake, a school really prefers the HydrAid filter because it provides a much greater volume of clean water for students and teachers each day. And as you can see at the bottom, it's the needs assessment. And this is our way of synthesizing the unique characteristics into a brief takeaway for each community.
So in addition to providing an outlet for the unique characteristics of each community that we visited, our community profiles enabled us to draw conclusions about the general problems that were common to several communities across the lake. For instance, we found that many communities suffered from a lack of training and follow-up after the installation of water projects. So many families would receive water filters without understanding what to do in the event of a breakage or who to go to if they were to need a replacement. Additionally, we found a general lack of sanitation education, so many families were receiving water filters and were involved in water projects without understanding the value of clean water or the potential implications of drinking contaminated water. We found as well that many communities had experienced a one-size-fits-all solution from water organizations. So a water NGO or a municipality would impose a project that wasn't necessarily catered to the unique needs of that specific community and would apply it universally throughout many communities around the lake. We realized that our project is very broad in scope, and this was intentional to enable us to visit several communities around the lake and to compare and contrast each community. However, we do realize that if we were to conduct further work in any specific community, we would need to conduct additional research to provide more detailed information. We also recognize that our status as foreigners may have influenced some of the information that we received, and we found that we received some contradictory information between interviews with NGOs and interviews with municipalities. So this is something that we'd like to further investigate to determine what the most accurate information is in each community. So our goal in providing and creating community profiles for each of the townships around the lake was to provide a streamlined portal for the characteristics and the water projects currently operating in each of those communities. We found that there were hundreds of water NGOs and water initiatives taking place around the lake, but organizations weren't necessarily aware of each other's existence or collaborating with other organizations that had similar goals. So our goal in creating a streamlined location for this information was to foster collaboration and sustainable relationships. We also hope to continue our work through the creation of a GIS map that would map the locations of water projects and water initiatives currently taking place in the lake basin. In sum, our project sought to address the issue of inadequate potable water access in Lake Atitlan. And we sought to do this through the creation of sustainable relationships between our group and our faculty mentors with our community partners in Lake Atitlan, as well as to foster future sustainable relationships between organizations working on clean water issues in Lake Atitlan. Our primary finding was that each community had unique needs and required unique water projects to cater to those issues. And we hope to conduct future work to further solidify community relationships and networks between organizations. Thank you.